Algebra 1, this is Chapter 3, Section 9. We're going to solve some mixture problems here. So let's take a look at our first mixture problem. I'm going to have a series of videos on this subject. I'm not sure how many I'm going to have at this point, but I'm going to start with this one. So Jerry likes to feed her cat gourmet cat food that costs $1.75 per pound. However, food at that price is too expensive, so she combines it with cheaper cat food that costs 50 cents per pound. How many pounds of cheaper food should Jerry buy to go with 5 pounds of gourmet food if she wants the average price to be $1 per pound? So let's grab and start sorting through this information. I have a table down here I can fill in, and the table's going to help me organize my thoughts. So Jerry likes to feed her cat gourmet food that costs $1.75 per pound. So that's the expensive stuff. The expensive stuff is going to cost, price per pound, $1.75. However, at that price, the food's too expensive, so she combines it with cheaper cat food that's 50 cents per pound. So the cheaper stuff is 50 cents per pound. We want to know how many pounds of cheaper food, X, should Jerry buy to go with 5 pounds of gourmet food, if she wants the average price to be $1 per pound. Okay, so I've got all the information filled in from the word problem that I know, and now I'm going to start trying to figure out what the other items in this table are going to be. So I know if I've got $5 of expensive food and 5 pounds of expensive and X pounds of cheap, we want to know how many pounds of actual. So if we've got 5 pounds and we're mixing it with X pounds, that would be 5 plus X. We're going to add the two together. Our expensive food plus our cheap food would be equal to our actual food. So when we're going down, we're going to be adding here. Then we're going to look at the price. We've got pounds, we've got price per pound. So we've got 5 pounds and it costs $1.75 for each of those pounds. Then we're going to be multiplying here to be equal to the third column. So I'm going to take 5 times 1.75, and that's going to be $8.75. And then I can do the same thing here. I've got X pounds. It's 50 cents per pound, so that's going to be 0.5X. And then I get to this last spot down here, and there's two ways I could fill it in. I've got my price of expensive, my price of cheap, and then my actual. So I could be adding straight down, right? Add straight down to equal that box. Or I can take my pounds times my price per pound and do a multiplication to get to that box. So I've got two ways to get to the same answer. So I can set that up as an equation. So I can take my $8.75 and add it to my 0.5x, and that will give me my actual total price. Or I can take my 5 plus x and multiply it times 1, and that would give me my total actual price. Now I've just got an equation with one variable in it, and I can solve it. So I'm going to collect all my like terms and get my variables on the same side. So I've got a 1x on this side, so I can actually probably rewrite this. So I've got 875 plus 0.5x is going to be equal to 5 plus x. So I want all my variables on the same side, so I'm going to move my variable with the smaller coefficient. So 0.5x is smaller than 1x. So to move that, it's a positive 0.5. So I subtract 0.5x from both sides. Okay, so if I've got 1x and I subtract a half, 1 minus 1/2 is 1/2. So this is 0.5x here. And don't forget our plus 5 here. This 0.5x minus that 0.5x makes it go away, becomes a 0. And so I get 8.75 is equal to 5 plus 0.5x. Then I'm going to subtract my 5 from both sides. Make sure I line up my decimal. So that's going to be 3.75 is going to be equal to 0.5x. And the last thing I want to do is I want to, get the x by itself. So I could divide by 0.5, because 0.5 is being multiplied by that. And whenever I divide by 0.5, I take 3.75 and divide by 0.5. I end up with 7.5 equal to x. Sometimes, though, I think of this. 0.5 is the same thing as 1/2, and to get rid of a half, I multiply by 2. So if I take 375 and multiply by 2, I actually get 270 or 750 also. So remember that 1.5 is 1/2, and you would flip and multiply, so you can multiply by 2. Those people that are ready for that in their math level. So our answer for x is 7.5. We need to go back and reread the question and find out what we needed. So we want to know, how many pounds of cheaper food should Jerry buy? How many pounds of cheaper food should Jerry buy? Well, here's our cheaper food, and this is our pounds. So x should be how many pounds we need. So we've got our answer. We just need units. So this is 7.5 pounds. And that is our final answer there.